Hi, this is an example problem on polarization from chapter 24. Pause for a moment to read the question. All right, so we got unpolarized light that is approaching from the left, from over here, and it's going to go ahead and pass through these two polarizers in sequence. And so these dashed lines, these are the transmission axes, where the polarizers are allowed to pass light through only in that direction. Okay. Now, to figure out how to do this problem, let's go ahead and look at some notes here. So, if you have unpolarized light and it goes through a polarizing material, you're going to have a decrease in 1/2 of the initial intensity, as it only one direction will pass through. Now, once you've got polarized light, if you approach a polarizer, then you're going to have a decrease by a factor of cosine squared of the angle between the incoming light polarization direction and the transmission axis. Now finally, if you have multiple polarizers in a row, we can go ahead and for each time you pass through a polarizer, it's just a multiplier that decreases the intensity. So the initial intensity on the left here, we start with that and we multiply by the decrease factor for each polarizer. So let's see how that works in our picture here. So here is our S initial intensity, and then after passing through, we've got our final intensity. So the intensity at the end is this. Oops. S average final. It's going to be S average initial, what we start with, and now I'm going to need to multiply by a factor for the first one. This is unpolarized light that's coming in, and so what comes out is going to be half of that, and now it's going to be polarized. So I got a factor of 1/2 for the first polarizer, and now for the next one, let's see what passes through. So here's the direction of the light. We use red for this. So after it passes through, the light is only oscillating in this direction. And so when it reaches over here, the light's going to come here. Notice what we have. We've got 15 degrees there and then 45 degrees there. So if we look at the angle between the transmission axis and the light that's coming into the second polarizer, we see that that total angle there, it's going to be from here to here 60 degrees. And so this is going to be cosine squared of 60 degrees. That's what this one is going to decrease by. Remember that this is the same thing as taking cosine of 60 degrees and squaring the whole factor, right? That's going to give us the output. So we can go ahead and put this in now. Our initial was 43 watts per meter squared. Then it decreases by a factor of 1/2 through the first polarizer, and it decreases by a factor of cosine of 60 degrees quantity squared by the second polarizer. Putting that into the calculator, it gives us a final intensity that's transmitted, which is equal to 5.38 watts per meter squared.